So this video is going to go through an algebraic reasoning of why this property is true. So we're looking at the property of n choose k plus n choose k plus 1 is always going to equal n plus 1 choose k plus 1. And in the previous video, we looked at where this got pulled out of Pascal's triangle. So this video is going to look specifically at symbol pushing. In other words, how do the formulas make sure that they align? So firstly, in terms of this particular formula, what we're going to do is I'm going to write out what the formula is to the side. Okay, so over here to the side, the formula for n choose k, and I'm going to go ahead and grab the formula that uses only factorials. So factorial, n factorial on the top, k factorial on the bottom, and n minus k factorial also in the denominator. And remember, the n factorial over n minus k factorial is the same as our following factorials. Okay? So what I'm going to do is I'm going to rewrite both sides in terms of the factorials, and then we're going to see that they're equal to each other. Okay? So here, we're going to go ahead and assume that n is some non-negative integer. So a positive integer, technically speaking, it's okay if it's 0 as well. We're also going to go ahead and assume that k has to be some integer between 0 and n. So k can't be bigger than n. Otherwise, the factorial isn't defined, but it can be anywhere between 0 and n. So then we'll actually go ahead and look at the formulas we care about. And if you're ever trying to verify a formula, you always want to take the more complicated formula and try to simplify it. That's a standard technique, and it also makes your life easier. So I'm going to go ahead and just plug in the formula. So rewrite this guy with factorials, being careful not to forget the factorial symbol. And then we grab the other one. So this one is an n up top, so n up top. And notice here we've got a k plus 1 on the bottom of that factorial. So in our formula, everywhere we had a k, we're going to go ahead and replace that k with a k plus 1, which means in our denominator, we'll have a k plus 1 factorial, and then we'll have an n minus k plus 1 factorial as well. Now, remember what we're trying to get to? We're trying to get to a single n choose k format, or really n plus 1 choose k plus 1. So this needs to be combined into a single fraction. So I'm going to do a couple of things. And the first thing that I'm going to do is notice the following. I'm going to say, hey, notice here, if you have a k plus 1 factorial, this is the same as saying k plus 1 multiplied by k minus 1, keep going all the way down to 1. Well, that's exactly the same thing as saying k plus 1 times k factorial. So I'm going to go ahead and factor out an n factorial from the top of both of these fractions. So that'll be 1 over something plus 1 over something. And I'm also going to rewrite our k plus 1 factorial as k plus 1 times k factorial, and that allows us to go ahead and factor a k factorial out of both of these fractions as well, which means in the first fraction you'll simply get left with an n minus k factorial, and in the second fraction you'll get left with that extra factor of k plus 1, and then whatever this stuff inside the brackets is simplified. Well, if we go ahead and simplify the stuff inside the brackets, we'll get n minus k minus 1 factorial. Now, using the same trick we just used for the k plus 1 factorial, I'm going to go ahead and rewrite these two factorials that are left on the bottom of our fractions, and you always look to check who's the bigger of the two. So the larger of the two here is the n minus k value. So if we look at that factorial expanded, it's n minus k times n minus k minus 1, and it keeps going all the way down to 1, and we say, hey, we get the same result as what we were getting in the previous line. So we'll get n minus k multiplied by n minus k minus 1 factorial. And that's a trick you can do with any factorial. Just pull out the top number that was in front of the factorial symbol, and you'll have that term multiplied by the one number less with the factorial sign on it. Now notice what this means. This tells us that we could rewrite this guy as that n minus k times n minus k minus 1 factorial, but we have that factorial part already in the other fraction, so in reality, we can factor it out as well. So notice so far what we've done is we've been able to factor out, well, almost everything. And the only thing we'll get left is the fraction 1 over n minus 1 for our first fraction. And our second fraction, the only thing that got left is k plus 1. And, well, the entire second part over there got canceled. So we really have these two much more simpler fractions. Now, what are we going to do next? Now we're going to go ahead and combine the stuff inside of brackets into a single fraction. So let's do that over here to the side. Okay. So if you have 1 over n minus k, you want to add that to 1 over k plus 1. We're going to get a common denominator. So since n's and k's can vary, n can be any non-negative number, k can be any number 0 through n. You don't necessarily know if there is a great common denominator, so we're just going to multiply the two together. So our common denominator is going to be n minus k times k plus 1. May not be the smallest one that's possible, but it always will work. To get the new top, we're then going to cross multiply. So the new top of the first fraction would be k plus 1, and the new top of the second fraction would be n minus k, and I'll keep the parentheses there just so it's easy to see which fraction they came from. Then you add. So notice when you add, you still get an n up top. The k and the k minus 1 actually cancel, so we'll end up with an n plus 1 on top, and on the bottom we'll have n minus k and k plus 1. Notice we now have a single fraction, which means when we substitute this back into our expression, we'll have n factorial on the top, k factorial on the bottom, n minus k minus 1 factorial on the bottom, and over the new fraction is the factor n plus 1, and on the bottom, n minus k and k plus 1. Now we're going to undo what we did earlier when we split our factorials. Notice here, we can go ahead and take the k plus 1 and merge it with the k factorial. And that means we'll get back a single larger factorial. So we'll have on the bottom k plus 1 factorial. We can do the exact same thing with the n minus 1. We can go ahead and combine it with the n minus k minus 1, and notice that's exactly the same thing that we did previously to the side in Scratchwork. So on the bottom, we're left with k plus 1 and n minus k factorial. Now the new thing that we haven't done yet is we haven't dealt with n factorial times n plus 1. But if we write that out, and I'm going to on purpose write the n plus 1 first, when we write out the n factorial, notice it's n times n minus 1 all the way down to 1. That's exactly the same thing as n plus 1 factorial. So we can also rewrite this top in a combined form of an n plus 1 factorial. So far, everything we've done is just symbol pushing with factorials and factoring. At this stage, remember what we wanted. We wanted to get to the formula of n plus 1 choose k plus 1. So we compare back to our formula. And our original formula said, well, whatever's on the top better be the top factorial. Check. We've got that. So there's our n plus 1. And then we want to make sure that whatever's on the bottom really works. So on the bottom, our k, we now have k plus 1. So the k would change to a k plus 1 factorial. Check. We've got that. And over here, this needed to be top minus bottom. So our last little thing of Scratchwork, top minus bottom. The top we want is n plus 1. The bottom we want is k plus 1. So the resulting difference will hopefully be whatever that factorial is that we actually have. Notice the ones cancel, so we get n plus 1. We have the n plus 1 factorial, which means, yes, this formula really does, in factorial format, really does equal n plus 1 choose k plus 1.